Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Fardi bin Abu Zarim and matrix number 250627. Alright, for today's topic, I will present about the inverse matrix. There are two types in inverse matrix. The first one is inverse matrix of 2 by 2 and second one is inverse matrix of 3 by 3. Alright, first one, you go to the first step. First type is inverse matrix of 2 by 2. For inverse matrix of 2 by 2, there are two steps over the inverse matrix of 2 by 2. The first one is you need to find the determinants. Alright, over here, I already showed you the matrix of 2 by 2. A, B, C, D represent the matrix. Why I color A, D in red and B, C in blue? Because this is the formula to find the determinant. Right, for example, negative 3 1 1 2. Okay, so to find the determinants, I times the negative 3 and 2, and then I get negative 6 minus 1 times 1, I get 1. Okay, negative 6 minus 1, I get negative 7. Negative 7 is the determinant of matrix 2 by 2. And then the second step is replace the result into the formula to find the inverse matrix. Inverse matrix formula is A inverse equal to 1 over determinant A, and times you need to, from original matrix, you need to change AD to DA, change the place from AD to DA, and for B and C you need to add negative. Alright, so if you don't understand, it's never mind. I will show you the example of inverse matrix of 2 by 2. Okay, so I will show you how to find the inverse matrix by using matrix 2 by 2. Okay, this is the matrix 2 by 2. Okay, for this matrix, first of all, there are two steps over here that I said before. The first step, alright, we need to find the determinant. Alright, as you know, the formula for to find the determinant is A D minus B C. Assume that this A B C D. Okay, I will do calculation. AD minus BC. Okay, A7 times D2 minus B4 times C3. Okay, and then you 7 times 2 you get 14 minus 3 times 4 times 3 you get 12. Right, 14 minus 12, and then you get 2. 2 over here is the determinant. Okay, this step 1 to find the determinant. So you know that the formula for inverse matrix is 1 over determinant D negative C negative B A, right? Okay, now we do the step 2. Inverse A equal to 1 over determinants times D negative C negative B and A. Right, this one. Okay, alright, and then 1 over this 2 for the determinant times what is D 2 C over here, then we minus it, minus
3, and then b over here minus b, and a 7. Alright, so you do the calculation, and then you will get, alright, this is the metric inverse for this equation. Alright,
Okay, I think you get it. How to find the inverse matrix of 2 by 2. Now we move to inverse matrix of 2 by inverse matrix of 3 by 3. In this inverse matrix of 3 by 3, there are 5 steps to find the inverse matrix. Step 1, you need to find the determinant, same like inverse matrix of 2 by 2. The second one, need to find the minor. What is the minor? The third one, you need to find the cofactor. The fourth one, you also need to find the adjoint. And lastly, step 5, you need to replace the result into the formula. What is the formula of the inverse matrix of 3 by 3? Is A inverse equal to 1 over determinant A ad, times adjoint A. So I will show you the example.
okay, now we do the calculation to find the inverse matrix for matrix 3 by 3. Get it? 3 by 3. Okay, I already teach you before this. For this matrix 3 by 3, you have to add on another column and row, but only at this one, A, B, D, E, and G, F only. A is 1, B negative 1, D is 1, E is 0, and G is 5, and last one, H is 3. Right? Okay, if you finish do this, you can find the determinant. I said before this, for matrix 3 by 3, there are 5 steps. The first one, find the determinants of 3 by 3. Second one, to find the minor. Step 3, find the cofactor. Number 4 is find the find the adjoint. And lastly, step 5, replace all the result in the formula. Right? Now we do for the step 1. Step 1, let's show it. Determinant. Alright, determinant. Okay, for this one, if you want to find the determinants, you just times A times E times I plus B times F times G plus C times D times H. Alright, I do it one by one. A determinant equal to 1 over 1 times 0 times 4 plus 1 times 0 times 4 plus negative 1 times 1 times 5. Negative 1, 1, and 5 plus 0 times 1 times 3. 0 times 1 times 3. Alright, you finish from upper to bottom. If you have 3 sections, this means all you need to plus. And then you have 4 minus, you have step from G times E times C minus H times F times A minus 4 times D times B, right? Okay, I show it to you. Do the minus first. 5 times 0 times 0. 5 times 0 times 0 minus, you have finished the session, another one. 3 times 1 times 1. 3, 1, 1. Minus, another one. 4 times 1 times negative 1. 4, 1, negative 1. Right? And then just do the calculation for this one, and then you can get the determinant for this matrix 3 by 3. 1 over 1 times 0 times 4 is 0 plus negative 1 times 1 times 5 is negative 5 plus 0 times 1 times 3 equal to 0. Right, every time you do the multiple, one, if they have 0 value over there, like this one, and this one, automatically you don't need to do the multiplication session, right? Because all the time, if they have 0 value, that's mean if you times 1000 value also is become 0. Okay, and then I do the minus this one 5. Yeah, see over here, yes, 5 times 0 times 0, that's mean the answer is automatically 0. Okay, minus 3 times 1 times 1, the answer is 3. And another one, minus 4 times 1 times negative 1 is negative 4, right? And then you calculate this equation, and then you will get 1 over negative 4. This is the determinant of A. Okay, now do the step 2. Do the minor. We want to find the minor for this one, right? Okay, we're going to the step 2. Step 2 is to find the minor. Alright, in slide I show you already how do you can find the minor. Alright, now we wrote back the matrix, and how to find the minor is A equal to, right, so we want to find the minor, A minor. I wrote sebagai AM means A minor. A minor, how to find? So if we touch A, all the row and all the column of A we close this one and this one. So it left E F H I. We're using the concept of AD minus BC. Okay, that's mean over here E times I minus F times H. Alright, so E is 0 times I 4 minus F 1 times H 3. Alright, so 0 times 4, 0, minus 1 times 3 is 3. Okay, and then the answer is negative 3. Okay, so I do it for B minor, same concept as A minor. Close the column, close the row. So 1 times 4 minus close 1 times 4 and 1 times 5. 1 times 5. Right. Means 1 times 4 4 minus 1 times 5 5. This means over here minus, okay, negative 1. Okay, after you do all the calculation for minor, and then you get a minor equal to negative 3 negative 1 negative 3 negative 4 4 8 and negative 1 1 1. Okay, this cofactor you need to add minus in B, D, F and H. Alright, so after you get the minor, change to the cofactor equal to negative 3, over here negative 4, and then you add another minus, negative negative, you get positive 4, and right back negative 1, over here negative 1, add another minus, and then you get 1, 4 over here stay, 1 over here you also need to add minus, it become negative 1, and another one 3 8 over here, add another minus, it become negative 8 and 1. This is the cofactor for this matrix. You go to next step is step 4. Alright, okay, I wrote back the cofactor. Okay, this is the cofactor. Adjoints need to change from the row to column. This means this row, change it to column. Alright, negative 3 1 3, this row to the next column, 4 4 negative 8, and this row to the last column, negative 1 negative 1 and 1. Okay, this is the adjoint for this, or we call it transpose from the row to the column. Okay, and lastly the final step is step 5. Replace all the result to the formula. A inverse equal to 1 over determinant adjoint A. Adjoint A means this one. Okay, so I write back the formula over here and I do the calculation. A inverse equal to 1 over negative 4 for the determinants and the matrix adjoint, negative 3 1 3 4 4 negative 8 negative 1 negative 1 and 1. Okay, you need to calculate 1 over negative 4 equal times negative 3, and the final answer will become, okay, that's it. That's how you find the inverse matrix of 3 by 3.